Hello everybody, Chris here, and in this video I'm going to be building out the platformer demo for my grid building plugin for Godot 4, which of course allows you to place objects into your scene during gameplay by snapping to the grid and then placing placeable objects into the scene. So for this demo, I'm going to be using Pixel Adventure, which is a really good platformer pack, public domain. So I'll be taking some of the assets and using that to build hopefully a reasonable working demo with object placement into the game scene. So I'll create a new folder here for platformer. So the main point of the video is to give you an idea of how you can take the plugin and implement it into your own game. So I'm doing everything from scratch. You can jump over the tile map stuff if you don't need that. But basically this video should serve as a good demonstration for how to get going with the project. Alternatively, if you do download the plugin, you'll be able to check out this exact demo and load it up into your own game project and test it, play around with it. So I'll create an art folder inside of the platformer. Inside of that, I'll call it Pixel Adventure. And to save on project space as much as possible, I'm only going to be bringing in the image assets, which I'm going to be using in the demo. We don't need everything here, we just need some of it. Okay, so I'll start by bringing in the tile set, which is called Terrain 16 by 16. So let's create a new level scene for the project, and I'll rename this to be Platformer Demo Level. So let's save this scene into the project platformer demo level.tscn. Now I'm going to bring this into the platformer demo folder. So inside of platformer, I'll create a new folder for levels, and I'll put the demo level inside of that. So for our demo level, let's make sure the name is still correct. Platformer demo level. Let's save that. I'll right click, add a child node. Let's get a tile map. So for Grid Builder to work, we basically need to be using tile map nodes for our game. But if you're doing side-scrolling platformers, or if you're doing top-down RPG games with 2D pixel assets, most likely you're using tile maps. So we should be fine with that. Okay, next we need to create the tile set. So I'll create a new tile set over here. This will just be embedded in the tile map. So if we click on that, then we'll get a couple tabs at the bottom. So in tile set at the bottom, we want to bring the terrain.png into here and automatically create the tiles. Okay, so that's going to separate all of these 16 by 16 tiles into their own thing. And the first thing we'll probably want to do here is to create a physics layer. So I'm going to go to physics layers, add an element, and we'll use collision layer 1 just as the default ground. If I want, I can rename the layers. So I'll just call that one ground. And while I'm ahead of things, let's just make layer 2 for player and layer 3 for enemies. That way you can have collisions on the ground, checking for the ground. But if you're checking for the ground, you're not necessarily checking for player or enemies. So for instance, if you're placing an object that needs to make sure it doesn't collide with the ground, but a player's in the way, it'll ignore the player unless you also target layer 2 with the mask on the tile collision indicators. We'll get into that more later, but that should be a good setup for right now. Okay, now that we have this physics layer defined, we need to set that up on our tiles. So let's go to paint mode and select physics layer 2. So I'll add physics collisions to all of these tiles by just left clicking on them, and that's going to copy whatever we have over here in the preview window into the tile. So we're just going to make a full collision on all of these tiles all the way around the square. That'll be most simple, and I think it actually works really well for these tiles specifically. Let's just add that in, and you can left click, hold, and drag if you want to be a little bit faster about this. As long as the tiles get their collision squares, that should be good. Okay, now the only exception here is probably going to be these tiles over here, which are kind of like small platforms. So if we want to shrink the size of our collision shape to match these platforms, then we can click on one of them and then bring these points up. But it might be better if we have snap to grid enabled. So if we click here, or rather click here, toggle grid snap, and then grid snap. Okay, so we're going to see this is 4 pixel grid. So that means we can go all the way up here to the first set of 4. So this will be 4 pixels down and 16 pixels across. So if we click on each of these tiles, that collision shape is going to suit us quite a bit better. If we really wanted, we could go another pixel down here and make that bottom pixel also collision, but might not be necessary. We can always come in and fix it later. Okay, so there's the collision for our tile map. Now if we go to tile map mode at the bottom, we can go to the paint tool. And so we could select tiles individually or as a group and just place them into the scene like that. So a quicker way of doing things would be to set up terrains and just have auto tiling select which tile we need when we're painting with these tiles over here for these brick tiles, or a different set, anyone we want to set the terrain up for. So let's try terrain sets, and I'll add a terrain, and this is going to be wood walls, I suppose. Okay, so with that there, and we only need to match this on sides since this is a pretty simple tile set. So we just need to basically show which sides have another wood piece inside of the pattern. And then it will automatically auto tile for us. So if we go to Tileset now and tiles, we can paint properties again, and we want to paint terrains. So let's select terrain set 0 and wood walls, and then we can start defining the terrain for these tiles. So let's add all of these to the terrain set. And now you can see you can click on each side in the center to define which sides have wood pieces adjacent to them. So all of them are going to have the centerpiece checked because these are all wood tiles. But here we have down and to the right. Over here we have right, left, down, and center. And over here, left, center, and down. And so on and so forth. You just keep assigning the sides as you would expect the sides to have an adjacent tile that is in this wood walls terrain set. Okay, so for these over here, I think we actually need to have match sides and corners. So I'm going to actually change the mode to corners and sides. Okay, so that just means we need to add these corners in as well. So all of these corner tiles are going to be filled in, of course. And we should basically have one big box around this area. So now for here, we have center and the bottom right corner. Here we have center and bottom left, center and top left, center and top right. Okay, so I think that's all we need there. If we go to tile map, terrains, and you might need to like refresh the editor or something in order to get this to show up sometimes. So we want to have this connect mode, and then we can just start painting onto the tile map like this. Left click and drag. And it may not work perfectly the first time. We'll just kind of see if we run into any issues here. Okay, so here I'm actually seeing that I had the bit mask wrong. So instead, what we actually want, this bottom right corner we see here, is actually the one where we don't have the bit mask. We want all of the other ones. So it's just those center corner pieces which don't have the bit mask, because these are supposed to fill in the corner gaps like right there. So let's test that again. I'm going to click there, and there we get our corner piece. So if I keep going around the circle, okay, now it's looking correct. If we come down here, yep, that basically works. Obviously, it's meant to be at least 2 tiles wide for this to work and fill in properly. But we can kind of get like a decent wall thing going on there. So we have some walls that we could actually make a character stand on now. So I'm also going to add in a folder here for characters. And this time I'm going to bring in the mask dude from the pixel art pack. So let's do that. I'm going to try to rename everything to be Snake Case before I switch back to the editor and have it load into the game. So I have mask dude there, then double jump, fall, hit, idle, jump, run, and wall jump. Okay, so those are going to be our sprite sheets for the animations of the character. All right, so before we add the character to the scene, let's actually click over here to make a new scene, and we'll make a 2D scene for this. So the root node of this is going to be mask dude. So I'll save this into the project. I'm going to be putting it in add-ons, grid building, demo platformer. And then we'll create a new folder here called characters. And just so you know, if you are trying to basically follow the tutorial with the grid building, if you're going to be making your own game or your own demo setup, you should probably not put it in the grid building plugin, because obviously those are going to get overwritten if you try to update the plugin. So don't do that. Put it in your own folders, not in add-ons. Anyway, let's have the characters here. I'll just make another folder for players, and I'll save it there. Sure. Okay, so with the player character, the mask dude, we probably want to make the root node the character body 2D so that everything inside of this scene can be affected by physics. So I'm going to right click on mask dude, the 2D node, and we're going to change that type to character body 2D. So this will make it so that anything under it can be affected by physics. So before we add a collision shape, which is what this warning is about. Let's add in an extra node, and I'm going to add it as a node 2D, and I would just rename this to be transform adjustment. So what we're going to use this for is flipping the scale between -1 and +1, and the reason for that is so that any child nodes where we'll put the sprites will be able to flip automatically, and we'll also be able to have any collision shapes under it that need to flip as well, being able to flip between left and right. So that would be really standard for a platformer game, a side-scroller, right? So if, for instance, we had a character that could swing a sword to the right, we'd also want to be able to flip that hitbox so that it could swing towards the left and hit the left. So this is one way of doing it, and I think I like this method. So now let's add in a sprite 2D node under the transform adjustment. So sprite 2D, okay, and now we need the character art. So let's right click here, add a child node, sprite 2D, and we could just leave it as sprite 2D for right now. That's fine. So I'll go into characters, mask dude, and let's bring in the idle sprite sheet by default. Okay, so obviously we're not going to show all of these frames at once. We're going to use the animation tab in order to set this up in conjunction with an animation player. If you're loading up your pixel art and you don't see it being clear, just go to project settings, and then you want to go down to rendering textures and make sure that your texture filter is nearest. That's important for pixel art, otherwise it will all look blurry. Okay, now let's add a animation player. I don't think it needs to be under the transform adjustment, so I'll just add it out here as animation player. Okay, and then we'll create a new animation here in the animation window. I'll call this idle. And then we need to go switch to the sprite 2D, and let's set up the number of H frames to match how many columns there are here. So 3, 4, 5, 6, 7, 8, 9, 10, 11. So we want to set this to 11 and keyframe it, hit create, and that'll add a property in the animation window. Okay, next we just need to add this in 11 times. So if I check the website, Pixel Frog suggests that this should be in 20 FPS, or every frame lasts for 50 milliseconds. Okay, so that's helpful because that means we want to set the snap to 0.05 seconds, 50 milliseconds. Okay, so now we go to frame 0, hit the keyframe button, and let's go to 0.5, increase this by 1, and then keyframe that. And then it should kind of figure out automatically that we're trying to increment this and jump to the next snap point. So snap to 0.1 with frame 2. That's what we want, and we can just keep clicking this until we get all of the frames, which this should be 11, so that makes it 0.55 seconds in here. Let's change the animation duration to 0.55 seconds, enable looping, and now we can hit play. And there is our idle animation for the masked dude. So we also, at a minimum, are going to want, let's say, the jump and the run animations. We can add the other ones in later if we wanted to. So I will add in jump here. Oh, and let's go back to idle real quick. We also want to keyframe the texture here. So we have to have this texture set so that the idle animation will actually work. So on frame 0 here, keyframe the texture. Okay, so we need at a minimum those 3 properties for each of our animations. Let's go to jump. Okay, so for jump, let's bring in the jump frame here. I'll keyframe it, and then we set H frames to 1 because it's a 1 frame animation. And then we will do frame 0 keyframe. So yeah, make sure the H frames was keyframed as 1. The frame of animation should be 0. Let's hit play. Okay, there. And now it's actually loading properly. For this, there's only 1 frame, so I guess we can just make this 0.5 second duration. And looping, not really going to matter here much. But there, basically, that's our jump animation. Let's see, do we have a fall? We do. Okay, so let's add in the fall animation. That'll be important too. So, fall. And I'll actually just go to jump, and I'm going to copy all 3 of these. Control C, go to fall, Control V. Okay, so now for fall, we need the sprite 2D. We're going to change the texture to fall. I'll keyframe that as the texture. Let's keyframe H frames, and then frame 0. Okay, and then we just need the duration, 0.05 seconds, looping, and we hit play, and that's our fall. Okay, so the last thing is run. So new animation, run. I'll bring run.png in here. Then we need to count columns. So we have 6 and then 12. So 12 frames, keyframe the H frame so that property gets set when we enter this animation. And then add in 12 frames. And make sure we're snapping to 0.5 seconds. And looping, and then this should be a duration of 0.6 seconds for 12 frames. Okay, now just add in the frames. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we are missing the texture keyframe, so put that in there too. Okay, hit play, and that's our run animation for this character. So those should be the minimum animations we need. Obviously, we can see wall jump and double jump are also in there. Cool things to add to a platformer, but a little bit unnecessary for this tutorial. Okay, so let's stop the animation and let's add in the default script for platformer to our mask dude. So I'm gonna right click on him, add script, and we can see we have character body 2D basic movement. I will just call this player.gd. I think that's fine. And let's create our script. So we'll add the class name, player script, up here at the top so that we can identify that this is a player object. So just something I like to do with this default script is rather than having constants here for the speed and jump velocity where we can't set that in the editor, I'll just make it an export variable where we can. So I'm going to hit Control R and rename wherever we have speed to be speed lowercase. Okay. And then here we'll do jump velocity lowercase. Since they're not going to be constants anymore, we're going to make them at export var speed and at export var jump velocity. Okay, so now we need to make sure down here that those got replaced as well. I thought I did, but I guess not. So jump velocity lowercase and then speed lowercase. All right. Now that the script's saving, you can see that we can change the speed and the jump velocity over here on the right. And in this default script, gravity works by default. We press UI accept to jump, but only when the character's on the floor. We can move using UI left and UI right, which is left and right keyboard keys. And then we'll move if we have a direction, and we won't if there's not. So that should actually work pretty okay for a super basic platformer character. Now, one thing I want to point out, the building system, when we actually get around to adding that, uses UI accept as the default action. You can change that to any action you set up. Just if you're using enter as your key for jumping, you're probably not going to also want to use the enter key for placing objects into the game world. So unless you're going to disable your character during building preview mode, you probably want to either change this or change the action on the build system. Just as a heads up, not a big deal, easy to fix. So let's add our mask dude into the game scene now. Okay, so back on platformer level, let's search for mask dude and bring in the scene. Just put him kind of randomly in there. And as long as he's above the ground, that should work okay. Now, we have no camera set up, so I think the camera is just going to default around the 0 area. But what we want to do is actually have the camera follow our player around. So let's add a camera to the demo level. So I'll search for camera 2D, add that in, and then let's add a remote transform to the mask dude. So mask dude remote transform. Okay, this basically points another object at this object, so we can have the camera follow the mask dude by looking at the remote transform. So remote path, we assign that to the camera 2D, and now the camera is gonna be centered on our mask dude. Now there's other settings you can put in the camera, like drag, if you want the camera to not be 100% centered, but basically has to reach a certain margin away from the center of the screen before it'll start moving. And I guess I'll enable the drag. I think that just makes it a little more interesting. So let's run the scene as it is. And okay, we can see our mask dude falls through the floor, unfortunately. Also, everything's really small. So to make the window bigger, I'm going to go to project settings, and let's make this something like 1280 by 720. Okay, to make things actually appear bigger on the screen, though, you want to use camera zoom. So camera 2D, I'll set the zoom to 2 here to start. Okay, and then we need to go into mask dude and add a collision shape. So in mask dude, let's right click here, add a child node, collision shape 2D. Okay, and then I'm going to hit W, and I'm going to move this sprite up here. So I'll turn off grid snapping for right now, and let's just hold shift and move this pixel by pixel up. The reason for this is that the 0, 0 point is going to be where our center area for the object is, or you could think of it as the sprite sort point. So if we are sorting objects vertically on the scene, and this is more important for a top-down game, but basically that center point is where objects get sorted based on their Y position. So I'm just going to kind of, in general, keep my characters centered where the center point is kind of their center of body mass, or basically around the area where the character is standing on. So I'm not going to center that on the face like this. I'm going to have it center more around the feet or the pelvic area of the character. Okay, now let's go back to collision shape 2D and add in a capsule shape. And then I'm just going to move this capsule shape up as well. Something like that. I think that the collision shape has to be a direct child of Mask Dude. If I move this in here, it's not going to recognize anymore that the collision shape is down here. But that should be okay. I don't think we ever need to actually flip this collision shape. If so, we could make adjustments to our scene layout. And then let's just adjust the capsule shape a bit more as well. I don't actually want the head to necessarily be colliding all the time. So maybe I will shrink the capsule shape a little bit, move this up. We definitely want the bottom of the capsule shape to match where the bottom of our character's pixel feet are. And let's go to where in the run animation we have the character touching the ground. So that's actually down here. Yeah, maybe we make the character a little bit wider with the collision, or a little less. I think that's fine. Anyway, as long as it's roughly like that and roughly matches our character, it should work okay. Okay, so now let's go back to the platformer demo level. We can see the collision shape this time. Let's run the scene and move with left and right and space to jump. And there we have a extremely basic platformer. But we definitely want to flip the character when we're walking left and flip it back to the right when we are walking to the right. So in the Mask Dude script, I'm going to add a flip function. So I'll add in here set character facing direction, and we'll base this on the direction input. Okay, so let's write pass for right now. And what we want to grab in the script is going to be the transform adjustment. So I'm going to add another export variable, and I'll call this export var transform adjustment, which is a node 2D, and we'll assign that in the inspector. So since this is like an internal reference that we do need for the script to function, I'm going to also add in an export group here, which is just kind of giving a name category to anything under here, the properties in the inspector. So this is just going to be called internal nodes. I guess we can go with that. Yep. Now on Mask Dude, we can expand internal nodes. So that's all the export group thing does. And we can assign the transform adjustment. So we're going to assign that to the transform adjustment. And then down here at the bottom, now we can take the transform adjustment and flip its scale to be either -1 or +1 based on if the direction is positive or negative. So we want to find the direction x and see if that is positive or negative. So let's create a var scale x, and this is going to be equal to the sign of direction.x. So what this is going to give us is either a +1, 0, or a -1. And that's going to be based on if the direction is negative, if it is 0, or if it is any positive value. So we can take that and we can assign that to the x scale on the transform adjustment. So we'll say if scale x does not equal 0, then we'll take the transform adjustment dot, let's see, scale dot x, and we'll set that equal to scale x. So if the direction is 0, we're just going to ignore it. Otherwise, it's going to be either 1 or +1, depending on if our character is trying to walk in the positive direction to the right or the negative direction to the left. Okay, so we just need to call this probably before the movement slide. So I'll just copy paste the function name in there, and we need the direction, of course. So I'll pass that as a parameter. Okay, and now we can go to our demo level, run the scene, and let's see. Okay, that's not going to work because we're only getting the left-right direction input here. So if we want, we can keep it like that, or we can actually get both directions for input, which I think in the long run probably is a little better. So instead of get access, let's actually get vector. So this is going to give us a vector 2D. So I think you start with the x and then you add in right. So we'll do comma UI down, I think is the positive. And then, hold on, let me see here. Positive y is UI down, it should be. And then we have UI up as the negative value. So when you drop on the screen, you're actually increasing the y value. And when you go up, you're going in the negative direction. Okay, so now we get the vector here. So now instead of checking the direction, we want to check if the direction.x does not equal 0. Then we're going to move. Otherwise, we will move, and we only use the direction x for calculating the x velocity there. Okay, and then we pass in the full vector as the direction to that function. All right, so we can run our demo level. Let's do left-right movement. Okay, and there we go. We have a flipping character, but we're not just flipping the sprite. We also flip everything that is under that transform adjustment node. Okay, let's make some more changes to our mask dude. So first off, his collision, I want him to look at layer 1, so he'll collide with the ground, but I want him himself not to be on layer 1, but layer 2, which I'm setting as the player layer. That'll make it later so that when we're building things into the scene, placing objects, that we don't look at layer 2, so the player won't be a collision shape that we need to be concerned with placing objects into the scene. Okay, let's also add in background from the Pixel Adventure Pack. So I'll grab in a few colors here. So next we're going to want to take one of these PNG background images and add it to our game level as a tiled background. So I'm going to right click, add a child node, and we're going to use texture rect as our option here. So for this simple platformer demo, we don't really need parallax layers or anything, and a texture rect is really easy to get set up as a tiled image that you can just stretch to whatever size you want. So I'll use texture rect, create that as a node, and we're going to want it to be on the top of the list here. So by default, whatever is on the highest order is going to show below the ones underneath, I believe. So we want the background to show below everything else, including the tile map, so it'll do well there. So let's select the tile map, and then over in the inspector for texture, we can drag blue.png over to here. And then we just need to take the stretch mode to tile, hit Q, and then we can take these corners and stretch them to whatever size we need. So I'll just grab this corner and drag it out here, and there you see we have our tiled background. So let's just make it way bigger than the level. I'll just put it like here kind of randomly and pull it out like that. And then if we zoom in, well, that's basically our background level. Now this is a really bright background. I think I'll try the purple one or the brown one instead. Or we could stick to blue, but then I can go to visibility and let's self-modulate, just make it darker. Maybe a bit more blue tinted. Yeah, that's not bad. That's not bad. Easier to look at, more like the color of the Godot UI, so that works. Now our character also is not actually switching between animations yet. So in the mask dude scene, one way is to use an animation tree for controlling animations, but we're only going to set up a few animations for this character, so I'm actually just going to tell the animation player to select the animation that we want at the time that it should be playing. So let's jump into the script, and I'm going to create another function inside of here. So I'll call this function update animation. Okay, and so we're going to want update animation to run probably right after the move-in slide, since the move-in slide, I think if I recall, that adjusts the velocity of the character body 2D. So we'll have an updated velocity that we can use inside of update animation to set which animation should be playing when the character is done with its physics process. Okay, so if we come into here, there's 4 animations that we basically want to control the state of, in a sense, you could think of it that way. In the animation player, we have idle, so if the character is not moving, no velocity, or approximately no velocity, then we'll do idle. If we're moving left and right and we're on the ground, we'll do run. If we're in the air, then we'll either be doing jump or fall, depending on if the velocity of the y-axis is positive or negative. And that should be all we really need here for controlling the animation, aside from getting a reference to the internal node of the animation player. So let's do export var animation player, and this will take an animation player node, of course. I'll save this, click on the root node mask dude, and okay, it hasn't shown up yet because we still have an error in our script, so I'm going to pass the update animation. Now the animation player pops up in the inspector, we assign the animation player node, and now we can use it inside of our script. So for the update animation, the first thing we're going to check is on floor. So if the character's on the floor, then we can play its ground animations. So I'll make a little comment here, ground animations. So if the velocity.x does not equal 0, we'll say for starters at least, that the character is going to be playing the run animation. So animation player dot play run. Okay, else, okay, we can zoom in here a little bit so it's easier to read. Else we're going to do animation player dot play, and we're going to do the idle animation. Okay, so the other possibility is that the character is in the air animations. And so if I recall, down is positive, so if velocity y is greater than 0, then that means we're falling, so I'll play the fall animation. So animation player dot play fall, else animation player dot play jump. Okay, and I gotta clean up the code a little bit, so that line should be fine, and that should basically be our animation playing. So in a sense, what we've set up here is a super simple state machine for our character. It doesn't really have any movement logic for it, but that's okay because we don't need to limit our character based on if it's running or idling or fall or jump. It's going to be running the same physics process code for the simple character. So we can get away with this just fine. So normally if I was going to make the character more complicated with like wall jumps and stuff like that, I'd probably create a logic state machine and tie that in with the animation tree to get the animations to play and connect to each other at the right times. But this is just a quick way of doing it. So let's go to the platformer demo, run the scene, and you should be able to see the animations playing. So there's our idle. If we move, we run, and if we jump, we get the up and down animation depending on if the velocity is positive or negative. So really, that was just a really simple way of controlling the animation through logic code, and that's pretty much all we did need for this character, at least, because the rest is going to be mostly actually adding in the build system and being able to place objects into our scene. So before we do that, let's make this level a little bit more interesting and add in some extra areas where we can actually interact with and place objects into the ground. Okay, so in the tile set, I don't believe that these tiles are going to work for the auto tile because there's not really a centerpiece. So if this was a set of 9 tiles and then there was a centerpiece that was just like these 4 corners, it would probably work all right. But it seems to be missing that tile. So we're just going to like manually assign tiles to the level. So if we select multiple of these tiles, we can draw them out at once, make sure eraser is off, and kind of place like that. If I take the middle tile, I can just extend it kind of like so, make a platform over there. So one of the next things you might consider adding are one-way collision platforms. So when I look at these tiles, I think of them as a tile that you would be able to drop down below, and you would be able to jump up and land on. So if you want to take these and convert those into that kind of tile, then we want to use physics layer 0 still. But we're going to tick this little box, which is polygon 0 one way, which means you'll be able to jump from down above it and land on top of it. Now, I'm also going to make sure that these tiles have a very small size of their collision shape just on top. Now, previously I made them 4 pixels. This time I'm going to actually take these all the way up to the top, and we could really make it just a 1 pixel boundary. Now, how it's going to work in terms of the code of the character is that when we press down, we're just going to move the character a couple pixels below. So as long as the collision shape is the size of the amount we're going down or less, then it shouldn't cause any problems, and we should be able to get that easy drop down below the platform to work. Now, of course, there's probably better ways to do it, but this is just a quick way to set it up for a platformer demo. So anyway, I'm actually just going to take this and make it 16, so every grid space is a single pixel. And then I'm going to, with the polygon 0 one way checked, I'm going to click on all of these. So then we'll have our 1 pixel collision landing area. Okay, so with those set up, we can go to tile map and paint with them. So I will add a test platform on layer 0, make sure eraser is off, and we'll put it right around here. So if we run the current scene now, we should be able to jump up onto it. So I'll go over here, we'll jump, and we land on the platform. But we can't drop down below because we don't have a function for dropping below platforms yet. So the simplest way I've seen is to create a function that moves the character's position by a couple pixels. And this is technically outside of the move and slide function. It's just literally moving the node manually. So the downside is, depending on the size of the collision shape, it is possible to get stuck. So it's not a perfect solution, but it is a quick one we can deal with for right now. So we'll have drop down, and we're going to take the position, and I'm going to add, let's just say 3 pixels to it. So by adding, oh, and this is on a position.y. So when we're adding pixels, we're actually dropping the character down. So we just change the Y position and we move it 3. Now this is only going to work on the tiles that have a one-way collision enabled. So basically something that's set up to be a platform that we can drop down. So now we want to go up to the physics process code. So we'll have something for handle drop down. And just like for jump, we're basically going to reverse that. If import.is action just pressed, and for the demo we'll use UI down. Of course, they recommend that basically these UI imports, you redefine your own actions that you're going to use. So you can just create your own later on and change the string here to the actual action name. But for testing, UI down works okay. And we're checking that we are on the floor. So we can only drop down if UI down is pressed and we're on the floor. So we'll run drop down if that's the case. Okay, so let's go into the demo level. And let's see if that little platform we can actually do that with. So I'm going to jump on top of it and I'm going to press down. So let's go ahead and run our little scene. I'm going to jump on top of here. I'm going to press down and our character drops down below. So currently it works pretty well. So for right now, at least for a testing version of that drop function, that should just do good enough. So I'm going to select tile map again, go back to tile map, and I'll select the terrain and just kind of paint around some walls for a kind of test level. So let's just kind of put some stuff in there. And obviously you can see it's a lot quicker when you actually have tiles set up to give a rough shape of the level than it would be to manually go and select each of the tiles. So just kind of where possible, filling in where the tile, which type of tile should be used, wherever it is supposed to go. Obviously it's not 100% perfect here, but it works pretty well. Okay, so that can do okay as walls for us to be set up in. Maybe I'll take these tiles and move them up here. So they're kind of annoying where they are right now. And let's just select those and drag them up there. Also select these, and then I'll paint a copy of it using the pencil tool. And we'll just kind of go down there. And I'll make sure that this just gets duplicated, the middle one. So the left and the right tiles are just the ends. And that should do just fine. Okay, so let's kind of test that a little more. So this is a platform, we can drop down beneath it. If we hit the ceiling, obviously that's going to stop our jump. And we can go over here and walk around a bit. Now, I do think our character does move a little too fast. So what we can do is just jump into the mask dude scene and change the export values in the inspector. So I'm going to nerf his speed a little bit and his jump velocity. So 200 and negative 300. I think that'll work a little better. Let's run the game. Okay, I think that's a more reasonable move speed and jump. It's still enough to get up to the platform, but not too ridiculous that we're hitting the head on everything in the scene. So that'll do pretty good for our demo. Okay, so in this demo project, I want to create an enemy, and then I want to turn that enemy into a placeable object. So we'll be able to just create copies of the enemy inside the scene while the game is running. So first we're going to have to create an enemy. So I'll go back into the art assets from Pixel Adventure, and let's grab something we can use. So there are a bunch of guys that are... So there's a bunch of little critters we can use in the project, so we just need to find something we like. So do we want to go with this duck character? Or maybe the fat bird? Okay, let's bring in the art for the Rhino character. So I'm going to just copy Rhino. Let's make a folder for enemy art and the platformer art Pixel Adventure. So enemies here. And then let's open that up in the file manager, this folder specifically. Okay, and I'm just going to take this folder, paste it in there, and I'm going to make everything snake case. So Rhino, we go in here. This will just be hit, the hit wall, idle, and run. Okay, and before we jump into that, I'm also just gonna expand this wall to kind of fill the whole camera area, I think. So just have the background kind of show in that center area. Okay, so tile map, we'll go to the terrains. I'll click on wood wall, and I'm just gonna use this bucket fill or rect fill to select a huge area and just make it that identical wall, like so. Okay, and then we have that down there, that down there. Let's run the scene. So I'll make that a little bit bigger. The camera can see quite far. So let's just make it plenty so that we'll never actually see the background on the edge of these parts of the wall area. So now if we run the scene, we'll just see that center area like so. Okay. Okay, now let's add a new scene for our enemy. So I'll do a new scene and let's call this Rhino. I'll actually retype this to be a character body 2D. Okay, and just like the mask dude, I'm going to want a transform adjustment, or no 2D, but I renamed to transform adjustment just to be consistent. And this character is going to need a collision shape. So I'll right click, add a collision shape 2D, but I won't set it up until we've added in the sprite. So in transform adjustment, let's bring in the sprite 2D. And we're also going to need a animation player to control the animations on the sprite. So let's go into enemies, Rhino. Okay, I can actually fix that. Okay, and then we need to grab the idle sprite sheet and assign it into the texture there. Okay, now just like before, we're going to create animations in the animation player. So I'll do idle. Let's go to animations. We're going to have to figure out how many frames there are here. So 5. I'm counting 10. So let's do 10 H frames. Okay, it may have been 11. Yep, okay, 11. So we don't see any of the other sprites get mixed inside of here for this frame. So we need to keyframe that. We're going to keyframe frame 0, and we're going to keyframe the texture. Okay, and now we just need to increment the frame until we have all 11 frames. So let's take the snap to 0.05, and we'll move the timeline to 0.05 as well, 0.05. And the duration should be 0.55 seconds because we have 11 frames. Okay, so let's zoom in a little bit here in the animation window. And I'm going to do frame 1 here. Keyframe. Okay, and then frame 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, right. So this goes from 0 to 10, and that's 11 frames. And let's move the texture keyframe over to the start. We want to make sure that as soon as the animation starts, we're using the right sprite sheet. Okay, and we also have run. I think in this video, at least, we probably won't add in any damaging mechanics to the demo. I might do that later on, but it's kind of unnecessary since the main point here is just to show off the build system. So let's add in run, and we'll do the same thing. Sprite, bring in the texture, put the snap to 0.05, and let's see how many frames we actually need. So looks like 6 H frames. So let's keyframe that. Let's keyframe texture, and let's keyframe the 6 frames in. Okay, so 1, 2, 3, 4, 5, 6. And then change the duration to 0.3, enable looping. I think I may have forgotten looping on the idle. So let's enable that and test it. There's our loop. And for the run, there's our little run. Okay, so let's take the sprite and move it upwards. Just like before, I like to have the center area be pointed more at the feet or this pelvic area for the character to be consistent. And I'll turn off snapping so I can get the character where I need it to be. So we should be centered left and right, but we're moving the Y position up quite a bit. Okay, so to be sure about that, you can just expand Node 2D transform. You can adjust the Y position, but probably not moving the X position because we do need that center. Okay, so then we make a collision shape to fit that character. So probably either a capsule shape or rectangle shape would work here. I'll try capsule shape first, and this capsule shape, I'm going to actually want to rotate it. So let's rotate it 90 degrees so that it fits the shape of the Rhino. I'll hit W to move it up, and let's bring it right around there and increase the size and the width. If we hit Q to go into selection mode, we should be able to expand over here just by dragging the points. And maybe we make the height a little bit bigger as well. Then I'll hit Q and just move this into position. Once again, one of the important things is that the collision shape snaps into position with the feet. Okay, and let's save this Rhino scene. I'll actually rename the Rhino to be Rhino without the H, because that's how the art pack was set up. Then just find the folder where you're saving your characters, and I'll make a folder inside of here for enemies, and let's save rhino.tscn. Okay, so now we could probably put a copy of the Rhino into the game level. So I'll search for Rhino. Let's bring in rhino.tscn, and well, I guess we want snapping to be disabled for that temporarily. And we'll bring this over here. Now, another thing before we run the scene, I'm going to jump into the Rhino scene, and I want the collision to look at mask 1, but I want to put the character on the enemy's layer and not on the ground layer. So arbitrarily speaking, I made ground the layer 1, layer 2 is player, layer 3 is enemies. If you separate the different objects in your game into different physics layers, you can control which things interact with each other. So for instance, for the build system, we'd be creating tile indicators that target layer 1 because that's the ground layer, and we want to make sure that we don't have any collision with anything that's on the ground or objects in the game on that layer. But we wouldn't actually be looking for layer 2, layer 3, player and enemies, because we just consider those to not be blocking the building of objects in our scene. And that's just something you need to figure out which characters you're going to put on which layers. And then your tile collision indicator templates can target the layers where you do want to check for collision and ignore the ones where you don't. Once again, I'll be showing that later on as well. Okay, so now let's go to the platformer demo level. So if we run this scene, we'll be able to see that the Rhino exists there. It doesn't fall through the floor. But if we run over towards it, we'll be able to walk right through the Rhino. So the Rhino has a character body 2D. We can see that cleanly, and the mask dude does as well. But their masks, as in where they're looking for collision, is only the ground. So our character runs along the ground, but it doesn't run into the Rhino. So we can pass through the enemies in this sense. Which is optional. Some games you might want to collide with every enemy, and then for some games, some platformers, you would just want them to hit you with a hitbox and have no other interaction with the player directly. So it wouldn't affect your ability to move through the enemy, just that they would deal damage to you, i.e. like Mega Man, for instance. Okay, but our Rhino doesn't actually move or do anything. So let's add a new script to the Rhino. So we'll just save that in rhino.gd in the enemies folder. That's fine. We can start with basic character movement, but that's not really going to do much for us because we're not creating a main player character. We're creating a simple AI for the enemy. So inside of here, we can still have a speed variable, and maybe the character has a jump velocity as well. So I'll change these to @export var speed. Okay, and over here we'll have @export var jump velocity as well. So the jump velocity we're actually not going to really use for anything. We would still do the same, setting the velocity.y equals jump velocity for a simple platformer jump, but we'd have to change the condition on when this character can jump, and that would basically be checking for its state in the game, like if there's ground in front of it or not, or if it's on the floor, those kind of things put together to give it the logic for whether the Rhino should jump or just keep running forward. For right now, I'm just going to cut that out. So we'll still have the gravity added to our character. And the direction is basically just going to be if it hits a wall or not. So if it hits a wall, we'll reverse the direction. But let's have a starting direction. So var direction equals, and let's just say vector2.left. So by default, the Rhino will always be running to the left initially. And then we can check if is on wall, then we'll reverse the direction. So we'll say direction times equals -1. Or really, it should just be the direction x that we're reversing. So direction x times equals -1. So we reverse it. And now we don't need this part. There's not going to be any input for the Rhino. It's an enemy. And then down here, we don't need any direction, non-direction logic. The character's just always going to be moving. So we'll just move those parts out and just take the velocity x equals direction.x times speed. And the speed is this bit down here. Okay, so that'll basically control the movement of our character, and it moves and slides. So let's see if that actually works. I'll go into the platformer scene. Let's stop and rerun the game. And we can see that our Rhino does keep running. And when it hits a wall, we reverse the direction. Now, we'd also want to reverse the direction the sprite's facing. So kind of similar to the mask dude, we'll go in here and we'll just tell the transform adjust to flip the scale around whenever we hit a wall. So let's get a @export var transform adjustment, which is a node 2D. I can do the add export group thing again. Internal nodes. So these are just nodes we need to set. So if I click on Rhino, expand internal nodes, assign this to the transform adjustment. Okay, and now when we reverse the direction, we can give a little comment here. Reverse direction for character and sprites. So let's do the transform adjustment dot scale dot x times equals -1. Okay, and now if we run the demo level, when our character hits the wall, it's going to reverse directions. So we have kind of a cheesy floating around Rhino. It would be a lot better if we had the animations playing. So let's set that up. So we'll have a function update animations. Okay, so basically we're just going to check if the velocity does not equal vector2.0. Then we're going to play the run animation. So once again, we need to get access to the animation player. So under internal nodes, @export var animation player, which is of type animation player. You do have to define it for an export node. And then down here, we'll do animation player.play, and that's going to be run. Else, there's only one other animation to worry about, so we'll do animation player.play idle. Okay, so save that, and then assign the animation player in the inspector. Hit save, go back to the demo scene, run it. And we should have animations playing, but it doesn't look like they are. Oh, yeah, of course. In order for this to actually run, we have to add it. I'll do it, I suppose, right after the movement slide. So just make sure that this function's being called. Okay, now we can go back here, run the scene. I mean, he moves so fast it's a little hard to tell. So maybe we have to slow down the Rhino, but I can see the animation playing. So let's take the Rhino. Oh, I'll change the Rhino speed in the base scene. And we'll just change this to 100 and maybe jump velocity of 200. So it should move slower than the character if we expand it. So if we run the scene now, we should be able to kind of see our little Rhino walking rather than bolting across the screen. He still can't damage the player. That might be something we'd want to add in. But let's stop the scene for right now. And I think what I'm going to do is take the camera zoom and I'm going to set that to 3. So if we run the scene again, we should be closer to the characters and the scene. So yeah, that's a little better. We want to be able to see the details of the game world we're actually playing in. So that will work nicely. Let's add a item to the game. Something that would be another physics object that could be interacted with in the game world. So in the Pixel Adventure Art, I'm going to bring in a folder for items. So let's open this in the file manager. So I'm going to bring in boxes, box 1. So I'll just copy paste this inside of here. Let's do box 1 and break, hit, and idle for the names of the files. Okay, so inside of here, let's create another scene for this box, and we'll make the box into a placeable object as well later on. Okay, so let's go ahead and create our box scene now. I'll create a new 2D scene. We can rename this to be box. I'll right click it, change type to be a static body 2D. So an object that doesn't move, but is still a physics object. Things can collide into it. Okay, then up here, we're going to want to add a sprite 2D. And we're going to want to add a collision shape. Right click, add collision shape. So for the sprite, let's bring in idle. And then the collision shape, we'll make that a rectangle shape. Now, right now, you'll see that this rectangle shape is bigger than a single tile. And when you're using the build system, tile indicators will be created for any square where your collision shapes spill over into, as long as those shapes are on collision layers that match the mask layer of the tile indicator. So if your tile indicator template for no collision looks to layer 1, it'll create indicators for shapes on layer 1. But if your collision shape's on layer 2, it'll just ignore that. So you can define which shapes are actually going to be used for the building system and which ones will be ignored by it in that way. Okay, but we really want this to match up with the tile map. So if we go back over here to the main scene, we can click on tile map and we can see where the lines are being drawn here for the tile map. So these lines, the orange ones, are the ones we actually care about. And I can see that on configure snap, if we click up here, it's actually offset in a unnecessary way. So let's set 0 here for the offset, hit OK, and we just want those lines to match up so that we know what we're actually looking with the building system. So matching lines is basically what you want. Okay, so that makes sense for the snapping for this scene. But let's go into the box scene. And here you actually want the grid offset to be 8. I think when I was building the Rhino and the Masked Dude, I was having a grid offset of 8. So the reason for that is that when we place our object into the main level scene, we're placing it into the middle of the tile. So the middle of the tile is going to be that 0, 0 point here. So we're going to want to make sure that we are centered horizontally between these left and right parts of the tile. But we can also see that the collision shape is going to spill over into other tiles, and that would mean that we'd have more collision indicators. During placement, that would mean this one box would take up, looks like 6 tiles, could be even more, depending on where it's centered vertically, 6 or 9. But we want to go into collision shape, and we want to change the rectangle size to be 16 by 16 or less, so that this box only takes 1 tile up for collision and placement. Now, if you do want the collision shape to be bigger, but it only to take 1 square for placement, I mean, that would be kind of weird because then the collision shape would be bigger than the placement area, but you could do that just by changing the layer to a different layer than the tile collision indicator would create templates for. Okay, so now that it's 16 by 16, we should be able to get it to be only 1 tile indicator template, 1 square on the tile map that we're taking up. Let's save this box into a new folder. I'll call it objects, and we'll just save box.tscn. We go back to the demo level. Let's expand objects, and I'll just bring in the box. So if we have snapping enabled, and I'll hit W to go to move mode, select the box, we should be able to snap to the center of these tile areas. So if you want to make sure everything placed in your scene is grid perfect, you would just make sure you're snapping to the center of these tiles by having grid snapping turned on and configure snap in settings kind of similar to this. Okay, so let's put this over. Let's try there. So this should make the Rhino kind of bounce back, and let's run the scene. Okay, so the Rhino, as you can see, basically just kind of goes back this way, but he can't actually fall down here because he's too big. So we could shrink this platform by 1 tile. So if we click on tile map, and then we go to tiles, we can take this tile with the selection tool, Q, to make sure that you are doing that, and just drag this over here. And now let's run the scene, and our Rhino basically is going to go down there. So let's run it again. Okay, and there you can see the Rhino basically just falls down there. So the box has actually changed its path. Okay, so let's actually get to the part of this tutorial, which is not just platformer specific, but about the Grid Builder plugin. So we want to make it so that we can place objects into the scene. We already have the objects that we could place, such as the box and the Rhino. Those would be 2 examples. You could also do power-ups, really anything you want to, as long as it's a scene that is a 2D scene, you can place it. So I'm going to start by creating a parent scene to this demo level. So this is a level we could load it up into any part of our game and run it, but many games are going to have multiple levels, so it actually makes sense to have more of a main gameplay scene. So I am going to create a new scene, and this is going to start with a node 2D. We'll just make it a base node, and let's call this platformer gameplay. I'm going to save, and we'll save it into the root of our demo platformer. So this will be our main scene to load when we want to play the game. Okay, so let's save that there, and then we'll add in our level. So I'm going to do that just by dragging the platformer demo level into here, so everything loads back in, right? So the level is its own thing, but we probably have UI components that sit on top of everything else. But when we unload the level, we don't want to unload our entire UI. It would be kind of inefficient, and then we need to reset everything up. And the building system is not part of a UI. It's not a control, but it is a node. And so we also wouldn't want to necessarily unload those system nodes every time that we reload the level. So that's why I set things up like this. You can kind of figure your own node structure out for your game if you want. So for the platformer gameplay, we need to right-click, add a child node, and we're going to do a building system. So let's create, and I'll pull this up here. And we're also going to want a grid targeting system. So the building system has a build preview mode. It allows you to place objects into the scene. The grid targeting system handles looking at the position of your mouse and snapping to individual tile positions on your tile map. So they both need a reference to the tile map. And the building system, of course, is going to be placing things at those snap positions for where your mouse cursor is over the tiles. But they work independently of each other. So what you can use to find the position and let the building systems handle things based on that position and the node hierarchy is through a positioner node. So that can just be any node 2D really. But I have a template in the project, the grid positioner here. So if you search positioner, you should be able to find it. I'll drag this into platformer gameplay. And if we jump into the scene here, you can see this has a grid targeter node. And that's just an animation that'll play to show that you are hovering over the node. So you'll know visually which node you're actually looking at with the grid targeting system and which one you're trying to build on with the building system. Okay, so this is a 2D node, but we don't want it in the game level. So I like to add another child node, node 2D. I'll call this one world. So we can load and unload levels from the world. But not necessarily delete the whole world at once. And then we can put the grid positioner inside of that as well. So the grid positioner sits in the world. And now we need to reference these inside of our systems. So if we expand external dependencies, how you set these is kind of up to you, but you do need these for the systems to work. So the user is the object that is technically being considered to use the system. So it should be the character or the logic that controls the inventory for your character. Now that doesn't necessarily need to be the 2D character body node. It can be a more abstract, just regular node that has an inventory attached to it. But for right now, I will make it the character in the platformer demo level. So what I would probably do is that when our level loads, I just target these systems and I set these properties so that they'll work properly, and we update that for each level. I think in building system, I also have a change level setup. So you can use this if you are loading a new level. So you just reset the tile map, the placed objects parent, and the user. Okay, so how do we get access to this character when we are putting a copy of our scene into this hierarchy? Well, we can right click here and do editable children. And now we can see all of the nodes inside of here. So let's take the building system and assign the user to the masked dude. Currently, we're not using a spend material resources rule, so the user actually isn't going to be relevant, but it's nice to have that set up in advance anyway. So let's assign the positioner to the grid positioner node we brought in with the animated sprite. The tile map is going to be the tile map inside of the scene. And the placed objects position parent, we haven't created that yet. So this could just be any 2D node where all of the objects we create are going to be set as children of that parent. So we could even just use platform at demo level if we wanted to. But I think a cleaner way would be to jump into the demo level. And we'll right click here, add a child node, and I'll just call this, and we'll add a child node, node 2D. I'll rename this to be objects. And then we bring the box inside of that. So we'll target this objects node. Okay, so now back in platformer gameplay, we can see the objects node. Let's assign that to the build system. So any new objects will just go under objects. And then grid and targeting system is going to need the positioner and the tile set. So it's really easy to set it up in the inspector with export variables if all of those objects exist within one scene. If they don't exist during editing, like you create them during runtime, then you'll have to assign them in code some way, however you want to do that creatively. So let's see. I think if we hit the scene, if we hit run scene now, we should be able to see the grid tile indicator. Okay, so that's working. That's cool. And so we can basically know which tile we're hovering over, but we can't really tell the building system to open yet. So for the building system to start the building process, we need to call set buildable preview, which takes a placeable. So this is a resource file we need to set up. And then somehow with our UI or button presses, we need to set the buildable preview in the building system, and then it will start giving us a building preview, of course. So in our platformer project, let's create a new folder for placeables. So I'll right click in platformer, create new folder, placeables. And then inside of here, I'll create a new resource, placeable. And we're going to place the box first. But then we'll create a placeable for the Rhino, because why not be able to place animals into the game? So create new resource, placeable, Rhino. And that's without the H. Okay, and then we need to just set up a couple things here for the resource file. So assigning data and the inspector. So for box TRES, the display name will be a box. The icon, we'll just reuse the same art from over here. So I'll take the idle and put this in here. Technically for an icon, it's better if you can get all of the image sizes to match up for how things get displayed in a list in Godot by default. It just seems to work better if you have equal icon sizes, but we can deal with what we have for right now. So the packed scene is the scene we want to instantiate into the game, and that is going to be the box object. So I'll just drag in box object into here. Tags. So if we want to tell the game that this placeable object is of a certain type, we can create tags. So we might want to create a tags folder inside of placeables. So I can create inside of here a new folder for tags. And with the demo UI components, I created a class called categorical tags, which also has an icon and a display name. So we can use that if we just want it to be compatible with those demo UI. But really, the demo UI is just an example. You can set up your UI however you want. So let's right click into tags, create a new resource, and we're going to be looking for a categorical tag. Once again, purely optional class. You don't have to use it. And I'll call this something like categorical tag prop. As in like an object that just kind of sits around the scene, stuff like a box or maybe a cup or a hammer on the ground. I don't know. So let's save that there. And we can assign this as a tag. So for the display name, I'll call it prop. And for the icon, I'll just reuse the box icon for right now as just an example of a prop. So in box, let's assign the resource categorical tag. And you'll notice I left the tags as a generic resource array. So if you have another version of tags you want to use for the placeables, you definitely could use that. It's just that for categorical tags, they'll be able to work with the UI. So if you have another version of any resource that you like to tag your files with, you can use that instead of the categorical tags. And then placement rules, we won't mess with that quite yet. Ignore base rules. So these would be the rules we set up on the placement validator in the building system. Base rules will apply to everything by default, but we can check this box if we want to ignore stuff like the default no collision rule and just be able to place anywhere in the scene. Maybe do that for like flying creatures or something like that. It's just an option you have. Okay, so we're also creating the placeable for the Rhino. So let's create an animal categorical tag. I will right click and create a new resource. And we'll call this categorical tag Rhino, or animal, actually. Inside of here, let's type animal. And we'll use the Rhino art as the default. Okay, but that's actually going to be a little tricky here because the idle is a bunch of sprite sheet frames. So I will use a atlas texture to grab exactly the frame we want to use for the animal example. So we expand our atlas texture. I'll bring in idle.png over here, and then we'll edit region. So let's just select the first frame, and I'll enable grid snap here. So let's grab the first frame. Kind of like so, but maybe we need to lower the grid step to 4 and 4 for this, just so that we can get right beneath the Rhino's feet. That's not quite working. Let's do 2 and 2. Okay, now can I snap? No, sorry, 2, not 42. And let's bring that down there. Okay, I guess that's actually best. We'll just perfectly crop out everything that's not the Rhino itself and trim the butt area a bit. And that looks good. So we'll hit close. And that'll be our icon for the animal tag. Okay, let's assign the tag to the Rhino. So the Rhino is an animal. And we don't need any extra placement rules right here. So let's go into the building system and settings. So we need to have a placement validator. You can create it just by clicking on the dropdown, new placement validator. So let's set up the rules for our building system. So we're going to start with just having 1. and that's going to be a no collisions rule. Inside of this resource, we need to assign the tile collision indicator template. Okay, so for the tile collision indicator scene, let's search the project for indicators, and we have this one over here, tile collision indicator 16 by 16 minimal. Let's open that up, and if we zoom in here, we can see that this tile collision indicator is a shape cast, so it's basically going to look in the area inside of here, and it's going to see if there is collisions in that area. So the logic side of the tile collision indicator will be able to check certain things, like if a tile is valid. So checking collisions is the obvious one. Checking if a tile is invalid can be another. So by default, a tile would be considered invalid if you are trying to place it over an area of your tile map that has not actually been used, does not have any tile information inside of it. But if you want to get a little bit more complicated, like we would want to for a platformer, we would add an expected tile custom data. So we would do that more with the tile collision exists indicator. So we can check beneath, let's say where the box is being placed, to make sure that the tile underneath is ground. So we can add expected custom data. We check that the tile underneath has a property like buildable, and then this has to be true. It has to be a buildable tile. And up here, there can't be any collision with this other tile indicator. So that's why you'd have multiple indicators for different rules so that you can set things up differently. Okay, but for right now, we'll just focus on the collision. So rather than using this indicator directly, I'll right-click it and create a new inherited scene, so that we can change settings without affecting the original in the grid building project. Since obviously if you update your plugin, those can get overwritten since those are files in the plugin, not part of your main project. So I'm going to add the inherited scene to the platformer project. I'll create one for indicators here, a folder, and I'll say platformer collision indicator here. I'll hit save, and then for the settings here, we're going to make sure that the mask is 1. We're checking for collision against the world, which is things like other box items or tiles that have collision. So we want the collision mask to be 1. What will happen is copies of this indicator will be created for every tile where a shape that's on layer 1 sits in the preview scene. So if the shape would be 6 tiles, like the collision shape, then we'll get 6 indicators, 1 for each one, and they each check collision individually. Okay, so let's close this and that, basically all the other scenes, and go back to the building system. So for this no collision rule, we want a quick load, and we're going to look for the platformer indicator that we just created, or created an inherited scene from. Okay, the success message and the failed message, those are only really important if you're going to be outputting the signal messages from the building system to a log. It's just a little extra information about why a rule failed or why it succeeded. So you can change the messages to whatever string you want here if you need them to be. And let's go ahead and save that. So we have a rule that will basically mean that if we're trying to place our collidable object into an area that already has a collision there, we won't be able to, it will fail, and then the build will not succeed. So in order to trigger the building system, it would be convenient if we used some UI. So I will add a new child node for a canvas layer. I'll just use that as the base for our UI. And then inside of here, I'll add a couple scenes from the base project, just templates we can use. So let's see, if we go to demo and UI, we'll come down inside of here. And we're going to want a placement selection UI so that we can have a little list menu to show which placeable object we want to select, and then assign that to the building system. So let's use the placeable selection UI template, pop that in there. External dependencies, we have to give it the building system. Okay, so if we look at settings, we can see open actions. We'd be able to set up whatever action we want here to be able to open up the menu, just toggling it on and off. So if you don't know how to do actions, you can go to project settings, import map, and you can show built-in actions like this. And you can add your own ones in over here. But since when people load the demo, they're not going to have actions defined necessarily. So rather than do that, I'm going to just put in a toggle visible button. into here, and then we'll just target the placeable selection AI. So when we want to build, we'll just use that toggle visible button. So let's find where that is on the screen. Okay, if we zoom out a bit, we can see the default locations of these UI. So they've been set with anchor points. So this should be in the top right part of the screen. And then the placeable selection UI, it should be kind of towards the right side. We can also check show at start so that they're just kind of automatically there. And let's run the scene. I don't know if the placeable selection will show up. Okay, actually looks like the toggle visible button is anchored to the top left. So I'm going to jump into that scene and change its default. So let's make that top right. Okay, and then I'll offset it by a bit. So let's take the position X and make that 1992 and 10 down for the Y position. Okay, so now if we go back out, since that's using anchor points, this should be basically at that same position. And if we run the scene, it should be nicely there in the top right hand corner. And now if we go back out to the main scene, we should be able to see our build button there and run this. And then we have the build button, which will open the UI. There's the UI positioned correctly. If we enable show at start and we run it, then it should show up there. Okay. And yeah, okay, toggling it with the build is working. So yeah, just really simple demo UI stuff. So the main thing you want to care about here is we use the categorical tags to create tabs on this UI. And then the placeables are what items are going to go into those tags. And they filter into the categories based on what tags the placeables have. So the placeables need to have categorical tags to show up in the menu here. So let's add in our two placeables. And that's going to be, if we go back into platformer, placeables, box Rhino, I'll just drag those in there, I guess one at a time, into the placeable slots. Okay, and then here, let's add in the categorical tags. So which tags do we want to show as categories in our menu? So let's do animal as the second and prop as the first. Okay. And now if we run this, we should have our menu pop up with stuff. Okay, so we have prop here, and animal has nothing because I think we haven't assigned it to the Rhino, but the box will work currently. So let's take the Rhino and well, okay, we do have the categorical tag animal. Interesting. Oh, it's probably because we haven't set up a display name and an icon in a packed scene yet. So Rhino scene goes into the packed scene. The icon is the Rhino again. So for the icon, we'll just do this thing with the Atlas texture again. So I'll do a new Atlas texture. And then we'll bring in the Rhino idle, edit region, and just grab the region where the Rhino is showing, but for the first frame. So basically like that. And then we'll hit close. And for the display name, we can put in Rhino. Okay, so let's go ahead and run the scene and test out our placeable menu. So as you can see, we have two categories. So these are the categorical tags, and then we have the individual placeables, which have been filtered into their respective categories based on those tags. So we can go ahead and select the box, and you'll see that this will snap from tile to tile as we switch between where we're pointing on the screen. And we can press the spacebar to place an object into the world. So by default, that conflicts with our jump button, of course, and you would, in your own project, you would redefine that into your own actions, both for jump and for the build system. And we can switch over to a different build items. So we use the Rhino. You can see we can move it around the screen. When it's in the preview mode, it's not going to run any of its code. But as soon as I start hitting spacebar to place it into the scene, we get a copy of the Rhino, which acts just like the other Rhino does. So as things are set up right now, there's no real collision that we need to worry about for placing for things like here, though we probably would want that to be a case. But we could just spam the spacebar and just add a whole bunch of Rhinos into the scene. So I'll just do that for fun. And then we have a billion Rhinos in our game. So if you're wondering where do you set actions for the build system, if you click on building system, I have it set up in input actions. So if you define a exit build mode action, and you can see that we have the default one, UI cancel, which I believe is just the escape key, then you can exit build mode by pressing that key, escape. Or you can change this into a new action name that you create in project settings, and then you'll go to input map, define your own action, assign the key, And then you just need to put the string there, and that's how you get it to respond to those actions. And then build action name for the actual placement. So you can see UI accept defaults to the spacebar on the keyboard. And those are things you're probably going to want to change. They're just set to those UI defaults because those exist in every project before you define them. So the next thing we want to take care of is the Rhino and the box placing into the scene. We want to see a tile collision indicator. So if we click on the build system and go to the no collisions rule, we can jump into the scene for the tile collisions indicator and take a look at its settings here. So looking at the tile collision indicator template scene, if we go down and we look at the, I think it's visibility or ordering, then we'll see that the Z index here is set to 0. So what we might want to do is take the Z index and increase this default number to a higher number, such as, let's say, 1,000. And that will mean that it will render on top of everything else. Really, in the default templates, I actually intended for that to default higher, so I will go ahead and fix that. But if we run the scene now with our Z index set, if we go to box, and now if we select the box, then we'll be able to see our tile collision indicator there. And if we walk over to here to this box, you'll see that there's a collision against anything in the world. If we press enter, or space rather, on those areas, then we will not be able to place the box, but we can place it right next to it, and then the next square over, and again, we can keep placing boxes into the scene. So just to make it so the build action and the jump key isn't the same, I'm going to change this bit of the script here, and we're going to make it input.get key, key pressed is key pressed, and we're going to do key V. Okay, so rather than define an action, I'm just literally going to use the V key for the jump. So press V to jump. Okay, and then you don't have to define an action because it's just looking at that key specifically. So if we run the scene and we hit V, we have our jump, and spacebar is still the build action. So if we run our main scene, V is jump, and we can still place with the spacebar. Okay, so that helps us avoid that little problem. Okay, so what about the Rhino? If we go in here and we press spacebar, then you're going to see that the Rhino just kind of pops up here instead of placing where we technically want it to be. So we would want the Rhino, when we place it, to not have any conflict with the game world directly. So rather than making a physics collision adding to the Rhino, which would knock our player around, what we can do is give it a area 2D that's only used for checking for collisions when we're placing the object into the scene, but not actual collisions during gameplay. So if we want to set that up for the Rhino, then we want to add a area 2D under Rhino. So our area 2D allows you to check for things inside of that zone, but it's not going to cause a physical collision. So it would be great if we want to just add a child node here. And we are going to add a collision shape, but this won't actually cause any physics interaction in the actual game. So if we bring this up here, I'm going to rename this to be placement shape. And the reason I put it up here is so that it's behind everything else. So we click on the collision shape, hit Q, and I'm going to snap it to these corners. So basically what's going to happen is this placement shape is going to be converted into tile indicators. And when we place it into the scene, those tile indicators are going to make sure that there's no world collisions inside of here because our placement shape has the collision mask in layer 1. But when it's in the actual game, as an instanced scene, this area 2D isn't going to do anything there. So it is what it says. It's just a placement shape. It's only used for making sure that the placement area is valid before we instantiate it into the scene. So if you take this placement shape, give it the layer 1, then the collision indicators will be added. So back in gameplay. So if we run the scene now with the placement shape added and we try to select the Rhino, then you'll see the collision indicators are added for all of the squares that we had the placement shape set up for. And if we place it into the scene, then of course it's going to be checking for collision. So if all of them are green, we can place the Rhino. And up here, if we hit space, we wouldn't be able to place it because there's a collision. Same for if we try to place the Rhino into the wall. Now you might see that adding the placement shape also means that the Rhino is going to block the Rhino for placement into the scene. That might be desirable, or you might not want that because you want to be able to have, like down here, a bunch of Rhinos and just to be able to keep adding them in. So there's a quick fix to that if that's something you want to remove. So we just need to remove this placement shape after the ready function runs for this particular scene. So if we add a script here, I'll attach a script, and I'll actually make this a new script. So I'll call it remove on load, and I'm not going to put it in enemies. Let's go back a couple of levels in the path. So platformer slash remove on load. I should give it a folder though. So I'll just create a folder here, and I'll call it scripts. Let's create that in there, and I'll call it remove on load.gd. So let's open and save it. So I'm going to create it, and I want to extend node, actually. So let's move that in there. And then on ready, we just want to queue free on that placement shape, which will remove it from the scene. But this happens after the tile collision indicators are created in the preview scene, so it shouldn't be a problem for us, and this will only apply to the active instantiated scene. So if we go to platformer gameplay and we run this scene again, now we can go to Rhino and place a whole bunch in. You can see that no longer is the placement shape causing a conflict when we try to place a whole bunch into the scene at once, but we still can't place against the world because those still have those world collisions that are preventing us from placing there. So with that script, I'll actually move it to the main project, and I'll put this in the next patch for the Grid Builder plugin, because I think it would be helpful to have. So I'll just go to the building system, and I'll create a folder for helpers. Let's put that in there, and I'll move the script into that folder. So I'll give this script the class name remove on load so you can find it easier. Let's actually give it a better name. I'll call it remove on ready. Best name. So remove on ready.gd, and we'll make sure the Rhino has it right there. So this will get removed when the scene starts, and that's a solution that should work for us. Okay, so another problem we're going to have if we try to place boxes into the scene is that we'll be able to basically place the box anywhere we want as long as there's no collision. So if I place a box there, I can place a box over here, and that's fine. If I try to place inside where the boxes are, we don't get another box. I can place on top, which would normally maybe be okay. But if we try to place up here in the middle of nowhere, we can still place the box. So what we need to do is have a way of checking the tile underneath where the character is standing in order to make sure that it is marked as ground. Okay, so first off, how do you mark a tile as ground? Let's go over to the demo level and select the tile map, go to Tileset if you don't have that open already, and go down to custom data layers. We're going to add an element. I'm going to call it ground, to be specific about it being down here ground, not just any buildable tiles, because you might add buildable walls or buildable ceilings in a platformer type game. So let's add in the data type of Boolean. So it'll be true or false. If it's false, it's not ground. And let's go over to Tileset now and paint. And then in paint, we want to paint the ground data. So select ground. I'm going to toggle this on. And you want to choose tiles that should be marked as ground. So I'm going to basically say that anything that you would be able to walk on like this is ground. So I'll just mark the tiles with the checkbox to be ground. Like so. Anything that's basically a top tile you can stand on. Except I'm probably not going to mark these platforms as ground because those are flimsy. They don't seem like they would be solid enough to build on. So I'll just mark the rest of these tiles, which have a solid top bit as ground. So I don't have to do all of them right now. I guess I'll kind of get them in there just cause. And if I need to change one, I can toggle ground off and select it. And then toggle back on and mark the tiles you need. Okay, so as long as the tiles you need are marked ground true, then that'll be all you need to do for the tile map part. For the box, let's go in here and we're going to want to create another area 2D. So right click, add a area 2D, and I will rename this to be ground check. So it's an area because it's not going to be dealing with physics, but we'll use it for creating the tile indicators in placing in our scene. So I'm going to right click here, add a child node, another collision shape, and in shape, we'll do new rectangle shape. 16, 16. I'm going to hit Q to move it, and then I want to drag this down below. So I'll hide this just to make sure that this is the right one. We're checking for the ground right beneath the collision shape for the actual collision. So this is just for checking the ground. This is for actual collision. And the way we make sure that the tile indicators get created separately is we take this and we put it on a different physics layer. So I'm going to make this layer 10 for placement check. And I'll toggle off one for the mask and layer. So we won't be using this for checking against the world. We'll only be using this as a placement check layer. This way, the tile indicators will only be created for this platformer tile is ground indicator template that I created. So to create that, I would just start with the tile collision exists indicator and then right click and move/duplicate that into the folder you need it. Or you can right click and do a new inherited scene if you want to inherit all of the properties if this ever changes. Or you can just copy it and make it its own thing. Okay, so anyway, when we go into here, the main difference is that the collision sprites are going to be a little bit different. So if we click on no collision sprite, this is actually being marked red because we do want to have that collision against the layer. And then collision sprite is green here. So if we have a collision on the tile, after the tile is considered valid, then that would actually be a good thing. And that's why we're using that as the color there. I'm going to rename this scene tile is ground indicator. Okay, just to make it a little bit more clear for me. Anyway, the main thing here that matters is that we set the expected tile custom data. So this needs to match the custom data from the tile set. So we set a key and a value. So the key is string, and that's going to be ground. And then the value is Boolean. So this is like just like before on the tile set. Well, we just need to add this key value pair. It's important that you hit that, otherwise it won't actually be in the dictionary. So for the tile to be considered valid, ground has to be true on that tile. Okay, now let's go to the main scene and we'll run it. So I'm going to select the box and you'll see that we have that new tile collision indicator beneath it. Now it's checking to see if the tiles are valid or invalid. If I go up here, you can see that the tile is invalid and that takes precedence over collision. So if I go down to here, we can see that the tile indicator is red, which means that there's no collision, but we would be able to place here, I think. So if I hit space, you can see we can place into the scene. Now there's a collision here as well, so it's marked green. Actually, for the indicator, I'm gonna reverse the no collision and collision because we don't need to check for collision with this rule. We actually only need to check if the tile is valid or invalid. So I'll quick load this one for the green texture with no B, and this one I'll quick load it for the red texture with no B. The way I had it up before, that would make more sense if you're also checking for collision. But in this case, we just want to show the green sprite after the tile is valid. Otherwise, we're going to show the invalid tile. So if we now run the platformer gameplay scene, it's going to visually make more sense. We'll select the box. If we go down to here, we get the green tile. I hit space. Now that that's been placed, we have a collision down there against this box. So it's basically already taken up, and that's not what we want. So therefore, it's red, meaning that we can't place there again. If we go to any other space that has the ground, we can place it, but we can't place it in the air, which is kind of what we were looking for there. So it does occur to me that being able to stack boxes might actually be something you'd want as well. So I will make sure to add that as a optional feature as well. But yeah, basically, we are making sure that we can only place the box when it is on the ground. So it has to be valid ground. So this area right here, where we have those platforms that we can drop down on, those are not considered valid ground. So therefore, we do not get the green tile indicator and we cannot build there. So one more type of item that we might want to be able to place into the game would be a power-up or a pickup. So we can create another type using that. And in the pack, there's a bunch of fruits we can use. So I'll grab the strawberry fruit and we'll turn that into a pickup real quick. So let's put that in, I guess, objects. I'll right click and do a new folder and I'll call this pickups. And then in the items folder of the art, we also want to add in the fruits folder. I'll right click, open this up, and then let's paste the strawberry in, and I'll rename it to be lowercase. So now we can take that and turn it into a new 2D scene. So let's create a new scene. This will actually be a area 2D as the base node, so I'll search for area 2D, and then we'll need a sprite. So I'm going to add a child node, sprite 2D. Let's bring in that. So we can see this is actually an animated sprite. So we could create a whole animation player for this, but it's really just going to have one looping animation. So a better option would actually be to right click and change the type to a animated sprite 2D. Now we can click on here. In animation, we create a new sprite frames. And then we're going to click on this button, add frames from sprite sheet. So we do that and then navigate to where we have the sprite sheet. So demo, platformer, art, pixel adventure, items, fruits, strawberry. Okay, and then we just need to separate this. So I think we have about 16 by 1. Let's see how off we are. Looks like we need more frames, so that might be 20 frames. So the actual number here is 17 frames, 32 by 32 pixel for each one. So let's select all of those frames, add those in, and we don't need to rename the animation. If we want, we can call it something like loop. The FPS should be 20, and let's find the center of the scene again. Okay, over there. So we want this to autoplay, and we can hit play on it as well. Okay, so that's going to be our sprite, basically looping for us to go ahead and pick it up. So an area 2D for an interaction to happen, we'll need to right click, add a child node, collision shape 2D. And this is going to be a rectangle shape, or actually no, let's make that a circle shape. For the record, in the build system, it does not have to be a rectangle shape in order for the square tile collision indicators to be generated. Basically, as long as those shape casts detect a shape inside of the tile, a tile indicator will be created for it. Okay, and so for this area 2D, let's do collision. And so the only collision we're going to have here is masking for the player layer. If we want the pickup to basically manage itself, where when it detects a player, it tries to add itself to the player. You can do it the other way around, where the player is constantly looking for pickups as well. Kind of depends on whatever makes sense in your head. So I'll say strawberry pickup. And really what this is going to do is just when it detects a player, it's going to remove itself from the scene. Now, generally, that would happen after you actually do something with the pickup. Okay, so let's go ahead and save the strawberry pickup in the project. So I'll put it in objects, pickups, strawberry pickup. Okay, now I also want to attach a script to it. It could just be strawberry pickup.gd, or maybe we just make a more generic script, pickup.gd. So I'll create that. And what I'm going to have happen on this is we'll connect it to a signal that area 2Ds have, which is going to be on body entered, and then we'll just call queue free. Now, normally would be you do something with the player's inventory or health total, like add 10 health, and then you queue free, and maybe with a sound effect as well. But we'll just simplify it just to show that it's technically working as a pickup. So rather than double click here and connect it to the script directly, because then you have to maintain these connections, I'm going to just put it in the ready function. So let's connect to ourself. So body entered, in quotations, body entered. And then we'll have the callable, which is the function we want to run, underscore on body entered. And let's expand this menu, and let's expand things so you can see. Okay, so we don't need the process function, but we do need a on body entered function, because it's only the player layer that actually is able to enter here. We know it's a player. So when the player enters, we just want to do our pickup thing for the player. And in this case, that's just going to be queuing free. Now, if you wanted this to be like a base class for pickups or something, you could write something like function pickup effect. And that could take the body that was entered, which is a node 2D. So target, which is a node TD. And I'm just going to pass that. So this is like a virtual function. If you inherit the script, or if you want to fill it in later, you can do that. So let's add in pickup effect that occurs on the target. And the target is actually the body that entered. So we'll do body node 2D. And I'm just looking over here at the signal to know just to see what arguments are going to be passed in when we receive that signal callback. Okay, so that's really basic, but it will work for us for right now. Okay, so we have our script attached to the strawberry pickup. Now, this one problem that's going to occur, which is that we have no tile collision indicator to check to make sure that we're actually placing in the game world. So if I go over to platformer gameplay and oh wait, well we haven't created a placeable for the fruit either. So let's go to placeables and create a new placeable resource. So resource placeable, and this will be strawberry. I can say strawberry pickup. Yeah, maybe that would be a little bit more specific. Kind of makes sense. And if that's the case, let's actually make it pick up strawberry. If we create more pickups, it'll be easier to, because they'll all be sorted alphabetically in this list of placeables. Okay, so we have the pickup strawberry. The display name will just be strawberry. The packed scene will be the strawberry scene. The tag will create. I'll right click create a tag, and that'll be categorical tag pickups, or maybe just pickup. Since animals isn't plural, I guess pickups won't be as well. Okay, so for our pickup tag, I'm going to call this pickup, of course. And for the icon, we'll use the strawberry image. But we're actually not going to use just the icon. So I'll use a atlas texture, and then we'll load in the atlas of the strawberry. That way we can just select one single frame. So I'll add it in here. Let's do grid snapping, and let's grab the icon for the strawberry. Maybe I'll make the steps bigger, 8 by 8, and now I can just kind of snap like this. 8 by 8, not by 8 by 28. Okay, there we go. Not sure if it's better to cut away the edges or not. Maybe I could. Like, okay, let's just do that. Alright, so we have our icon for the tag. Let's look at the pickup strawberry. We want to do the same thing here. We want to do the atlas texture. And we're loading the atlas of the strawberry. Strawberry.png. I'm going to, so I'll edit the region here, and then let's get this area just like before. So it's a strawberry with the icon, the packed scene, the tag. Let's add in the pickup tag here. So I just drag and drop that, and then placement rules. I don't think we need any extra ones. So let's just make sure that the strawberry can be referenced in the UI. So in the placement selection UI, let's add in the pickup tag as a new element. So tag pickup, so we'll have 3 categories. And then we add the placeable, which is the pickup strawberry. And we'll run the scene. So over here on the new tab, we do pickup, and we can place a strawberry basically anywhere in the scene that we need it. And we should be able to jump into the pickup and have it removed from the scene. So basically working as intended. Let's see if there's any flaws here. So I think we can place it in the wall still, which in a way could be weirdly interesting, but it doesn't really make sense for this game. We want to make sure that when we're placing the strawberries, that we're actually avoiding the collisions with these areas. But obviously, our strawberry doesn't have its own collision shape. It shouldn't really be a physics object. So instead, we'll create another area 2D for placeable area. And on that placeable area, we'll mark layer 1 as the collision we're looking for. And then we'll just make sure that we're not colliding with anything on layer 1 in order to place the strawberry into the scene. So in the strawberry scene, let's open this up. I'm going to right click, add a area 2D inside of the area 2D. And this is just going to be placement area. I'll right click, add a child node, collision shape 2D. And we'll make this a rectangle shape of 16 by 16. And then the collision area on the placement area should be layer 1. And that might be all we need to do, actually. So let's close some extra scenes and just go into platformer gameplay. Let's run this. And let's go to the pickup tab and get the pickup object and see if we can place it into the scene. So over here, we cannot because we have the collision against the walls. So we can't place the pickup in the wall, but we can place it everywhere else. On the ground, in the air, on the ceiling, even on top of the Rhino. If we hover over our character, The preview doesn't get eaten up, but as soon as we place it into the scene, our player just consumes the pickup. So we can just keep placing this around. This also means that we can't have a stackable pickup for the strawberry by default. I guess we could get around that if we wanted to be able to allow it to stack in one spot by using the remove on load script, just queuing free on the placement area once we don't need it anymore. But I think as it is right now, probably makes a little bit more sense. If you had too many pickups stacking around in the same area, then that would actually be a problem for us. So we have the Rhinos. We can instantiate those into the scene, as many as we want. We can create our strawberries. We can go and pick them all up. And of course we can still make those boxes. And the boxes, once again, they have to place on the ground. So that's pretty much most of what we'd be looking for in terms of placing objects into a platformer game or a side-scroller, Metroidvania, whatever you need. So one thing I'm definitely going to work on is making sure that we can stack boxes if we want to. So I'll add that into the demo scene as soon as I figure that out. But for now, that's pretty much going to be it for this video, showing the creation of the platformer demo for the Grid Builder plugin. And I'll just kind of tweak it and revise it until it is good to go and can show off some of the features of the grid building system. But for now, I think that's pretty good for this tutorial video. It's been going on a long time. So if you got this far, thank you for watching to the end. I've been Chris, and I will see you guys in my future video content.